does that lead to?
Oh, it leads to a little cove where we used to keep a boat.
Oh, let's go down there.
Well, no, it's a perfectly dull, uninteresting stretch of sand, just like any other.
Oh, please.
Well, all right, we'll walk down and take a look if you really want to.
If you love listening to this show, please consider giving a rating and a review on Amazon Alexa or wherever you listen. We want to continue bringing you this amazing content, and part of our ability to do that means that we need a big audience. Now, it may not seem like much, but rating and reviewing the show will help more people find us, just like how you found this show. Simply on any podcast platform, search for a show, scroll down to the bottom, and push 5 stars. It's that easy. Thanks for supporting the show. Today, I'm joined by Dr. Prasad Akella, who is the founder and CEO of Drishti. Welcome to the show today.
My pleasure, Scott. Thanks for having me.
All right. So you have a PhD in robotics from Stanford and, of course, serve on editorial boards of robotics and computer integrated manufacturing and have been awarded numerous accolades in robotics. I mean, clearly, robotics has been just a big aspect of your life. I wonder if you could tell us a little bit about when you early on in your maybe academic career, when you figured out that robotics was really what you wanted to pursue?
Yeah, that's so I think the first time I actually converged on that was when Raj Reddy, the robotics pioneer at Carnegie Mellon, came to Bangalore and gave a talk. It's got to have been sometime in the late 70s, something like that, early 80s when I remember that being. And the whole idea of taking mechanical engineering, electrical engineering, and computer science and bringing them together to do something was really what caught my fancy. I like to believe I'm a little practical, and so just sheer mathematics wasn't of interest. I want to make things happen. And so that's really the first time as I think back, when I decided robotics was what it was. And if you remember, that was the heyday of robotics. There was this expectation of transforming the entire world, of putting robots on the moon and doing whatever else one had to do. And I guess I bit the bug there.
Well, it's very exciting, and I think you hit on something that's really we kind of take it for granted today, but this notion of multidisciplinary approach, right? So, I mean, AI in itself is a very broad field, but there's vision, there's hearing, there's even smell and movements and so forth. So being able to bring in all these different disciplines and integrate it in a way, really, I can imagine intellectually, but from an applied science application perspective, it was very challenging. It's very much project oriented as well. Is that right?
Yeah, one of those lessons I've learned over my life is you make massive strides in technology when you take two apparently disparate fields and you bring them together, right? So I've seen this in my own life. We were one of the founders of a company called Spoke. We effectively created business social networks. Today, you and I use it more as LinkedIn, but when we actually sat down and said, okay, you take this sociology problem, you take the sales problem, and you take this mathematical problem of graph theory, and you take this computer science problem, how to build this massive graph, and you bring them all together, suddenly you open up $1 trillion opportunity, right? Whether it's music, Spotify trying to help you pick up, music, or LinkedIn trying to connect you to people, or Facebook trying to connect you to ideas. It's the same thing. It's the idea. It's a whole notion of who knows who and who knows what. Taken from a simple graph, which is the biggest graph on the planet when we started, was 1,000 nodes. Academics had built graphs with 1,000 nodes. And we took it to 35 million, and today it must be some billion, whatever LinkedIn has. But massive jump in capability because of that coming together of disparate fields. So that's what I find particularly attractive. When you look at history, you'll see that happening.
I agree. I think this notion of distant domains, analogies, and then overlapping it into the domains or the areas of solution that you're looking at, it's fascinating. Which brings me to my next question is, at GM, you were involved in really the creation of the world's first, what they call cobots or collaborative robots. And it really was a major breakthrough. And I wonder at that time how it was viewed and why it was so important.
Yeah, the history of that's interesting. I was hired by GM to come in and solve what at that point was a potentially $1 billion fine from OSHA, the Federal Occupational Health and Safety Agency. And the situation on the ground, quite simply, was that people were picking up stuff. So, you have in the automotive plant, you got a body shop where a bunch of robots weld the car. You get the paint shop where a bunch of robots paint it. And then you get to what's called general assembly or final assembly, where a boatload of human beings actually stuff the car. And if you do the job, just pick up a battery 1 a minute, that's how fast the line runs, and try and lift the battery and put it in the car and go back and do that for 8 hours. I swear to God, you will sort of say, oh my God, how do people do this? And rightly, the OSHA came back and said, you've done this, this has been the path for like almost 80 years, 100 years. You guys got to change something. And so that's really the genesis, somebody coming from the outside forcing the change. And it was the same thing. There was no obvious answer because you had robots which were very good at lifting heavy things, and you have people with brains who could figure things out, who compensate for manufacturing variations. And the real question is, how do you take the human brain and the robot power and marry them in a manner that is safe? Because robots have always been caged. And if you look at the world, your power steering in your car is a classic example of that. You're the driver, you're in charge. But you got this big, car, 3 tons, battling down the highway, and you're responsible. And you got this thing called power steering that's amplifying your control on the car. It's the same concept. And it was, initially, people were perplexed, but then I think the idea caught their fancy, and it took a while for it to start rolling out. So in fact, one of the biggest lessons I learned from that exercise was the power of purchasing. We were an R&D team. We were building out. I was working with academics from Northwestern and Berkeley. I went and brought Ford into it because I realized this is the kind of stuff that needs market momentum behind it. And it was only when I went to the worldwide purchasing team and I said, guys, I need your help. And they called a meeting of, 100 suppliers, is when the thing took off, because suddenly the suppliers got a signal that GM and Ford were interested in driving this into the market. They were not interested in building it themselves, but they needed help building it. That's when it took off. So I think the signals were very clear. It took a while to get to this point where Universal now is a big, big company, but it's just fascinating to see technology grow and evolve over time.
It's really, really interesting. I think this insight, and we kind of get into this towards the end, which is around lessons learned, is this notion of the market's readiness and the market adoption, and certainly, especially in fields that are highly scientific and technical, the innovations or the inventions can be ready, but if the market is not quite receptive to that, or at a certain scale, the business hasn't quite caught up with it. Now, just to kind of move things along a little bit, is that we've seen a lot of changes, a lot of enhancements, and really incredible things happening on the automation side. Mm-hmm. But at the same time, there are still tasks that are just kind of really just better suited for humans. Mm-hmm. And that is interesting because what you're doing today, which is in the area of action recognition, is interesting because instead of applying the computer vision and the AI side, video onto the actual machines, you're actually applying it to the humans that are doing this manual assembly. First, if you could talk a little bit about what are humans best suited for, and do you foresee that those tasks could eventually be overtaken by really sophisticated, robotics?
You may also like our quarterly Ask Perkins event that brings some of the most notable experts and category-leading startups in their area of sustainability and human survival on Earth and in space. To register, visit astroperkins.com/events.
Yeah. So I'll say that most tasks will eventually get automated. That's just a given. You look at the Boston Dynamics humanoid robots, they're just mind-bogglingly amazing. And I remember back when Raybert's lab at CMU was trying to look at a pogo stick and trying to balance it 35 years ago, and how far they've come. So I think that's a given. That's a force nobody's going to stop. The real issue is today, there are really two issues. One, we've got 345 million people around the world building stuff that you and I cherish, your car, your TV, the computer we're talking on, the phone we use to talk. And it turns out that it's one thing to manipulate bits, it's another thing to manipulate atoms. So when we're building stuff, we're actually manipulating atoms, and it's a much, much, much harder problem than simply sending an information signal from A to B. And I think that's where humans excel. I'll give you a little example from my own PhD thesis. My PhD thesis was on trying to design robotic hands and trying to control them. And it turns out you and I are very good. You can pick up, this mouse here and completely have it under control, as opposed to if I try and do the same thing with what robots are, 2 ballpoint pens, you try and do it. This thing is fundamentally unstable. It'll never stay there. So how do you take the jobs that these 345 million people do and automate them? It's going to take us hundreds of years. Why is that? Supply is not there. We only build 350,000 robots a year. And 350,000 robots will take many decades to replace 345 million people. So that's the first problem. The second problem is a sheer engineering problem. Like I just said, controlling robots, getting them to the point where you can unleash them on these relatively tricky jobs. Putting a phone together is not an easy job. Is the second challenge. So I think that what we've done at Drishti is we've automated the data creation part using AI. So you have a choice. Either you create information or you actually do the job. And we're saying doing the job is going to be very, very hard. So now if you've got people like you and me who do things differently, who are variable in the morning with coffee and me, I'm different than without coffee and me. Yet you want consistent products coming out of the door. You got to close a loop on ourselves, and the loop is an information loop. And what we've chosen to do is automate the information creation so you can actually provide feedback. I'll give you a spell checker is probably the best example of this. You and I write email every day. We want to look good in front of our audience. We make typographical errors, we make grammatical errors. That spell checker is closing the loop on us, saying, little squiggly line, fix it. Incredibly empowering, because our brain doesn't have to worry about the details of that. We're more focused on the conceptual parts. It's the same thing. As the guy on the line, I want to get the main parts done. I want to make sure I'm doing the best job I can. Yes, I'm going to do things slightly differently, or maybe I forget something, and here's a little spell checker, Drishti, saying, go check that. So this is man-machine coming together in very, very simple yet important ways. And that's what we're shooting to do.
So I want to actually spend just a few minutes on the term Drishti, because that's quite interesting. And it has actually many religious references, as well as many different meanings, actually, including developing concentrated intention, or even references to 36 glances. So my question is, why did you decide to name the company Drishti? And how are you providing this level of immediate insight into the entire manual assembly system, like you're talking about?
Yeah. So as with most words in many languages, including Sanskrit, there's multiple uses of the word Drishti. So Drishti also means vision. And so in our case, what the play on words is we have a new vision for manufacturing. We believe since Henry Ford, Frederick Taylor, Franklin Lillian Gilbreth, nothing's really changed in the world of manual assembly. And we think we got a different perspective, a different vision on that. So that's the first play. The second is we're a computer vision company. And unlike most companies, we're creating a new data set using the next generation of computer vision, what you referenced earlier as action recognition. Essentially, Google figured out how to mine text. Siri and Apple figured out how to mine voice. Drishti is figuring out how to mine video. And computer vision is the very heart of that process. So Drishti comes from our recognition that there's a new vision, computer vision, and this yogic interpretation that you put in, that you talked about a short while ago, which is giving people that kind of guidance, feeding them through to where they go, is the source of the word drishti. And I find it fascinating because my marketing guy, Dave Prager, sort of pushed back and said, Prasad, people cannot pronounce this name. I said, you'll be surprised how people will figure it out. And so he couldn't come up with a better name. So I think it's, we finally concluded it's a beautiful name. And that's the reaction from the marketplace as well, when they do their homework like you just did.
Beautiful story. And, I think in order to actually look for these human mistakes that are, again, not the kind of individual nuances, but things that are clearly affecting the productivity or even safety from an OSHA perspective, and looking for these quality control root cause analysis of the people, and you're doing it on a real-time basis, there's some real complexity involved because video, at least the way you guys are processing, can be fairly heavy in terms of data. So how do you go about stripping out what's unnecessary so you can start to look for movements or patterns that would indicate some sort of outlier behavior?
Yeah, very fascinating questions. I'm just going to frame the problem slightly differently. People often think that it's the human that's making the error. Yeah, we do make mistakes. There's no two ways about it. But oftentimes it's the process that is the real issue. Because you and I want to do what's right, and we will do it if we understand it and if the process is set up to be robust. So our focus is on the process, much less on the person. And you've got 3 shifts, 3 different operators. They're all having the same challenges. It's not the person. It's the process that's at sort of in question. So the real question is, how do you process the video? How do you process these variations that are being viewed, and how do you provide that feedback in real time? I think this is where Krishnendu, my co-founder, has sort of blazed the trail for the world. We've essentially architected our own neural network, so we don't use stuff that's publicly available. We've architected our own. And as you can imagine, the world of neural networks has looked at 2-dimensional problems for the most part. You look at an image and you say, is there a dog there, a cat there, a stop sign, whatever else, a red light, whatever else happening in an image, and you process that. For us, we've got to process the video stream because the action of picking up a screw can be started by you slightly earlier than me. And so there's an entire temporal dimension of the problem. So our solution lives in 3 dimensions, X, Y, and time. And that essentially means we've had to solve the problem completely differently. Even a simple thing like annotating data. When it starts and when it ends means the accuracy of our metrology platform, billing, phones one every 60 seconds on a line. If we don't get the timing correct, the customer is going to come back and say, your measurement is off. And that measurement accuracy depends on our annotation accuracy, because time is so important. So we've essentially, much like Henry Ford, we had to build out an entire vertical stack ourselves. And the stack, if you think about it, starts with like a Nest-like capability to stream this video to the cloud, a YouTube-like capability to store it, a Google-like capability to search it. In parallel, we've got the ability to annotate data for training. And then we got a real-time engine, what you started your conversation with, to actually process the video flowing into our system continuously, 15 frames a second, and do a round trip to the cloud and back to provide me, the line associate, the feedback. And we do that using, think of it almost like a little iPad sitting in front of me, providing that feedback so that the spell checker is telling me I made a mistake or not. And the trick in all of this lies in identifying what's relevant and irrelevant in the field of vision. And so part of what Krishnendu and the team have come up with is these neural network architectures is to figure out what's important and what's not, what's relevant to the action, what's irrelevant, and what's important not just from an XY perspective, but from a temporal perspective as well. And I think that's the crux of what we've managed to do is solve that extremely hard problem very efficiently, because you're round tripping in a matter of a couple of seconds here.
So I really like this conversation, because rarely in most contexts do we talk about the dimension of tempora, this notion of time, which again, from a physics, it makes perfect sense. So when we think about the cycle time, bottleneck, benchmarks, it all has a dimension of time built in it. And being able to annotate the start and the end and properly with precision consistently is really important. So I think really fascinating. And I wonder, because you used the analogy of essentially workflow instead of workflow in a ERP cloud context, but workflow in terms of a manual process, assembly process, is how do you then not only benchmark, but how do you actually suggest changes or reconfiguration to that process so that you have better throughputs and higher quality?
Don't forget to visit astroperkins.com to register for our next quarterly events. Past and current speakers include Damian Vaughn, former NFL player, Neil Gregory, Chief Thought Leadership Officer at the IFC World Bank, and many more. To register, visit astroperkins.com and click on Events.
Yeah, lovely question. So if you think about the iterative production system or lean more generally, there is the trigger that identifies an abnormality. So once you got the deviation identified, then there are standard tools that let you go back, debug, fix, and measure again, right? So a Kaizen event is one such event. You say my throughput is low, and so clearly my line is not balanced. I need to go back and make sure the workload on the different stations is approximately the same. Now, what we do there is that first we beyond statistically significant, we're sampling 100%. We can tell you exactly what the issue is, which station is taking longer. In fact, we can do that even as the job is being done within 5 minutes. So this notion of time, we're compressing it from, I can do maybe, a Kaizen every 2-3 years, which is the state of the art right now, to in 5 minutes, I can tell the team leader on the floor, he's got an issue at a particular station. So we're able to look at that, look at the temporal signals, look at the action signals and say, I am seeing a deviation here. And that is the core sort of activity because that triggers everything downstream. And all of the tools become available to us to execute from.
It's absolutely fascinating, it really is. And I wonder, I want to ask a little bit kind of a strange question, which has to do with moral hazard. Is that in the example you gave of spell checker, let's say, we have the liberty, the creative freedom to write the content or the copy we want on a Word document. But the automation is going to look for grammatical, typographic issues. But there's a level of kind of enforcement. So in other words, if you take that even further to kind of a moral hazard or other issues is censorship in the case of, let's say, certain actor states that censor their people and what they can actually write that gets published in the public domain, for instance. So though this is really looking for patterns and efficiencies, in the case of, let's take an example of a very large brand that I'm not going to mention that has warehouses and many humans working alongside robots, where there are issues with not only individuals, but also, just their behavior. And if you take a very, very extreme example of China, there's been cases in the factory floors where they won't even let them use the bathroom and they have to use bottles to pee in. So there's another level of oversight where it becomes draconian, I guess, in a way. So how do you ensure that this instant feedback to the floor manager as well as to the individual doesn't become too much where it starts to kind of impede into basic freedom and rights?
Yeah, perfectly wonderful question. I get asked this every single time. So the excuse me. The starting point of that answer is the following. First, measurement of what happens to the plant floor has been the norm for 100 years. That is the give and the take that occurs on the plant floor. Because if the team that's building a product doesn't do it to the standards required, unfortunately, another team's going to win. So if my car company can build the product to whatever cost structures the market needs, unfortunately, that car line or that plant is going to get shut down. So there's a simple need here, which is a joint goal of building an economic product, a quality product that both the company and the employee share. And now, from our perspective, what we're doing is really we're empowering this person to do a better job. So in other words, unlike most of AI, which replaces people, I'm not interested in replacing the person. I'm interested in making that person a super person. And that is where there's a goal alignment between the person on the floor, Drishti, as well as the customer, because I'm not asking anything different from the person. And it's sort of like Moneyball. If you go back to the idea of Moneyball, the idea was you have a team of 11 people, each one has their own skill, and you find the person who can do a job the best, and you create a batting lineup to optimize the outcome. It's exactly the same thing. I know you can do a particular job well. I'm not good at that, but I'm good at jobs that you're not good at. And so if I actually can think of this in an enlightened way and say, I'm going to build a line that's efficient, uses my skill and yours, provides me feedback so I can do whatever I do better, this is a win-win. Now, we've not had data like this ever before. So we could never do all of this. So this is more about abstracting from the individual through this to the next level up and figuring out optimization at that level, rather than saying I'm here to censure somebody or to control somebody or punish somebody. In fact, we don't take deals where we find the culture of the customer to be punitive. It's not my intent. This is about getting somebody to retire safe, healthy. It's about getting somebody to enjoy the job. And there's another part to this. It's the HR side. So as an example, today, we assume that everybody on the line is equal. They're fully replaceable, as Henry Ford wanted it to be. But the fact is they're not. So I'll give you a little example from one of our customers. We noticed that on a particular station, there was a huge variation in time to install a rubber hose into a plastic sort of connector. Friction, flexibility, all of this led to that. And we noticed that in certain periods, that variation would reduce. So we looked at that and we found that this gentleman would show up with a glass of soap water. He'd dunk his tube into the soap water and stick it in there, and it went in every single time. We call them the brilliant outliers, these people who are creative on the floor, who do things differently than everybody else, but under normal circumstances would never be recognized. So this is the kind of character you give the hardest problem to. Say, here's my hardest problem, go fix it. And he or she will come up with a creative idea, and now suddenly there's a promotion path for that. Because their unique capabilities are recognized. Like you and I have unique capabilities over our careers, they've been recognized. We're giving them opportunities they didn't have. And so as long as you think about this data as at an aggregate level, as aiding the person, as benefiting both the company and the person, then we have goodness. If it's punitive, then we have badness, and I would say Drishti walks.
Now, you said something a few minutes ago, which is around this notion of supply. So it's interesting because I think there's a kind of a myth of what people think and what the reality is. So there's actually lack of industrial robotic arms. There's probably lack of cobots, and more so because of general trend towards not just relying on global supply chain distribution and manufacturing, particularly from China. There's both a strategic and a policy move towards building things inside, or I should say more regionally and domestically, I should say. So and semiconductor is a great example of that. So I think one of the things we're going to start to see over time is this greater demand to have more insourcing of manufacturing capability in the U.S. and the respective nations for their countries. So the bigger issue is really it's about training. It's about shifting the former retail worker, shifting the former truck drivers or others, and then retraining them. And when you're doing that in a large scale, how do you ensure that they are trained and doing things properly when in fact the final product, something like an electric vehicle, is of utmost importance because it is a very potentially dangerous weapon on the road in terms of if it's not manufactured with perfection and accuracy and integrity and rigor. So to me, that's the real benefit is the potential scaling and training and adherence to certain policies. I want to ask you, and because we're running a little bit short on time, is where can this technology that you built go as the market moves, as some of these macroeconomic aspects move? where is the company going in terms of product roadmap?
Yep, got it. So I'm going to first pick that training question up. You absolutely nailed it. So if you look at the Toyota production system, there's the notion of standardized work. The idea that everybody does the job in roughly the same way, in the right sequence. I'm not going to tell you pick it up in this way and do it. It's not a robotic definition. This is a process definition. Because if you have a baseline, then you know what to improve. And when you make an improvement, you know whether you actually improved or you didn't. And it turns out the uniformity in quality, the uniformity in productivity comes when you have that baseline and you train people to that baseline. And it turns out, even more importantly, coming back to your last question, when I have that brilliant idea that changes the base, changes the standardized work definition, you move the needle forward. And now that's how you make progress, because I'm adding my creativity to this definition as a line associate. It's not an engineer telling me what to do. I'm on the floor, I'm figuring it out. And it is that central idea of training of ideas, improving the baseline, standardized work, and essentially iterating forward. That's absolutely central. Coming back to your second question, where's the company going? I think what we're doing is looking at people at work. This is not just about manufacturing. It happens to be with starting in manufacturing. So I'll give you a couple of examples that'll make immediate sense to you and the audience. You mentioned an unnamed company in the warehouse business. It turns out humans are picking, they are packing, and they're shipping stuff to us. Kiva robots are merely tugs, smart tugs going from point A to point B. All of the rest is done by human beings. And so that's the part of the stuff. The second is you go to the pharmacy. The pharmacist gives you a medication, antibiotic, and gives you an antipsychotic. You can catch that. So I think that what we're talking about is far broader than just manufacturing. It's about people at work, and that's fundamentally what we're building towards.
Well, I wish we had more time. We are completely out of time for today. I've been joined by Dr. Prasad Akella, who is the CEO of Drishti. Thank you for joining today.
Thank you, Scott. I had a fun time. Take care.
If you've enjoyed this episode, take a moment to rate our show on any podcast platform that you listen to. Scroll down to the bottom and push 5 stars. It's that easy. And as always, thanks for listening.